Okay, so day 5 is about ellipses. So you knew the parabola, you had one focus. However, plural is foci, so you have two foci. And this ellipse, if I were to create this ellipse closer, as far as move these foci closer together, what do you think the ellipse would do? And the ellipse is this part right here. What do you think it will do if I were to move those foci closer to one another? It would form a circle. So when they finally touch each other, it's going to create just one. We don't call it foci, we don't call it focus, we call it the center of a circle. Okay? So, let me show you another one here. And here you can see A is the value with x. Okay? So A right here, this has a squared. That means if there was a let's say that there was 36 there. If I take the square root, this horizontal would be 6 units long. If this number over here, it was like x squared over 100, that means it would be 10 units long. Okay, that's xy. So that's the difference between A and B. Right now, A is 5 units. That means this is 5. B is 3 units. That means this is 3. And what we're going to do is we're going to look at, as it changes, look what happens to the shape. So let's make A bigger, and then let's make it smaller. Then let's make it negative. So it kind of flipped on its axis, and now it's going back to an oval, going closer, closer. There's a circle. So at the instant when A is 0, it's a circle. Actually, right there-ish. So here, when A is 3, why is it a circle right now? Because B is 3. Because these two are the same. Because A was left and right and B was up and down. Okay? Now, the same thing's going to happen with B. To me, it's all about the shape. Which one is showing the smaller side? Which one's showing the bigger side? Okay? So the bigger the number is underneath whatever letter, like if B is bigger than A, then it's going to be a vertical ellipse, because vertical is with Y. If the bigger number is underneath X, then it's going to be a horizontal, because the bigger number is showing the X, the horizontal ellipse. Pretty straightforward, okay? That's a default intro into it. Now let's look at the forms. So equation-wise, if you look at the form, so ellipses, if you look at the form of what could they look like in different forms, standard form, parametric form, so on and so forth. This right here is your parametric, and this right here is your standard. These are the two main ones, but of course we will need to know the general form as well. Well, you took a quiz over today, gave you a lot of stuff in general form. We completed the square, and we were able to get it to this form here. We did that with parabolas just now. The only difference here is a circle does not have to equal 1. Ellipses do. So we're trying to get this as 1, and another thing that the circles did not have are denominators. I mean, it's 1, if you will. Whereas in the standard form for the ellipse, the standard form A will tell you how long is it x-wise, and the standard form as far as B will tell you how long is it vertical-wise. Okay? Now look. Notice the center can be found right here. So HK is exactly what you see. HK over here in standard form is the opposite. Parentheses shows the opposite. But over here in parametric form, whatever you see, you just take it for face value. Why do you think they have these two? What did they used to be for a circle? What did A and B used to be for a circle? Just radius, and they were both R, right? Because they were saying not only is it the radius, but they're both the same value. Here they're showing one is A and one is B, because they're showing you that they're not going to be equal. Because if they were, it'd be a circle. So down here, A is not equal to C in this format. If A doesn't equal C, you can already tell that it's going to be an ellipse of some kind. Most importantly, from the last two shapes, is that you'll see if you're adding these square pieces, it's an ellipse. If you're subtracting, I'm trying to help you memorize, or not memorize, but read the chart. If you're subtracting the square pieces, it's going to be a hyperbola, which we'll learn next class. Because of the fact that this adds here, a good way to remember is that it will always subtract from the squares to get the C, which is the distance between the center and the focus. Okay? Okay. Think of a parabola. If this is the vertex and this is the jump, what letter does that represent? P. So over here, C is representing from the center to the focus. One of them. Okay? Just like P from before was showing from the vertex to the focus. You with me? Subtle changes, but there are differences. Okay? Let's go on to, this is the drawing exercise that we didn't have time to do, but you could see Miss Hamilton has her piece of string here that if she were to put a pin or whatever, you could see it draw the thing that I first started this video with. Okay? Alright, so let's move on now. And what are the applications? It's really cool. There's on a road trip one time, side of the road, it had this building. There was this building that was in the shape of an ellipse of some sort. And it was an elliptical room that it was like a dome, if you will. And it was three-dimensional, of course. And right here where the focus was, you could stand here and you could stand here. And this person could be facing that way. And this person could be facing this way. And they could talk to each other. It would go out, and this would come back here. So obviously if they were facing, they could hear them. But this person could project his voice this way, and it could go back, and it could go all the way in where the other person could hear it. Why? Because of the shapes of ellipses. There's many applications, because sometimes surgeons will attack a tumor. Not necessarily do they have a straight shot to the tumor. Sometimes they do have to get creative with these, not shockwaves, but like lasers, and find ways to reflect so that they can still perform surgery in that respect, and those kind of aspects. Kind of an analogy would be, if you can't attack that tumor straight on from the side, let's say that you work on cars or whatever, there's bolts or whatever that you can't get to, that you have to use crafty tools or whatnot, or you have to approach from a different side or a different angle just to get to the bolt that you're trying to lose. That's the same thing here, okay? But it's dealing with the shape of the ellipse. Now, triangulation is another thing here. Notice that if you look at this shape, you can pinpoint where something is from the same approach. As far as it's still going to go to the other focus no matter where your shot is. Just like whenever we did ellipses, no matter what angle this came to, like this light bulb, shine the light, it would reflect straight out. No matter what angle, it would reflect straight out. Why? Because of the curvature, otherwise the properties of the conics that we're learning right now. Circles, parabolas, ellipses, and hyperbolas. Okay? So, a couple things. We'll do this and then we're done for today. Standard form. Who can tell me from this what the center of this will look like? Go ahead. Negative 1, 3 is correct because it's opposite of what you see in parentheses. How much do I move to the right and left from the center? Anyone? 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. How much am I moving up and down? 2. So 1, 2, and 1, 2. So if I wanted to draw this ellipse, it would look something like, actually, let me not fill that in. It'll look something like this. Okay? Now, parametric form has x equals y equals. We said the center was negative 1, 3. Okay? And we're going to add, it's always adding, always adding with the ellipses, okay? And we're going to add how much cosine? 5. And how much sine? Notice how sine is with y, cosine is with x. More unit circle kind of applications. Okay, let's go to this standard form. We know we're going to result like this. Okay? Fraction plus a fraction is equal to 1. It's not a circle, it's an ellipse. What from here told me immediately that it's an ellipse? A does not equal B. Nice. This 3 is not equal to this. Can someone tell me, by looking at the parametric equations, what's the center of this ellipse? 2, 0. So we're going to say x minus 2, and then just y. You could say minus 0 plus 0. It doesn't matter. You don't need to write anything there but just y. Since I'm jumping 3 to the left and right from that center point, can someone tell me what number goes underneath x squared? 9. Okay, you see what I'm doing? Because it's a squared. Remember, the standard form is x minus 8 squared over a squared plus, and you have it in front of you, that formula chart, over b squared. So think of a as 3. So when I square it, I get 9. What would the number be underneath y squared? 34. There's your standard form. So at 2, 0 is the center. I'm going to jump 3 to the left and 3 to the right. And then I'm going to jump up and down root 34, which is about, I think, 5.83. 1, 2, 3, 4, 5.83. 1, 2, 3, 4, 5.83. And if I drew that out, I'd have a picture that looks like this. Which makes sense. The bigger number is underneath y, that's why it's bigger that way. Where the bigger number here was underneath x, that's why it's bigger that way. Okay? And the last one. What does that center look like to you? -2. So 4, -2, it's going to be x minus 4 because it's opposite. Y plus 2 because it's opposite. Now we just got to figure out what the jumps are. It jumped how many left and right? 3, so we're going to put 9. How many up and down? 2, so we're going to put 4. And now we can put our parametric equations as the center is 4, -2. And what's the rest of the x, guys? 4 what? Plus 3 cosine of t, and how about y? Plus 2 sine of t. We'll leave it off there, and we will pick it up next time.